Bam. All right, class. Good Monday morning to you guys and the last class of the year. So I see you guys in a year from now, or at least next year. How about that? Next year be a year wiser, year older? Kinda, maybe. I'm not sure. Well, hopefully we are. All right, let's go with it. We talked about plans for the winter break, which is like, we'll see. Anyways, let's go with it here. We're going to try to finish up this section. So 1.6 will at least be done. And then as we come back next year, we'll do 1.7. Okay, this one, a little bit boring, I got to say, even for me. But it's just we're reviewing all the functions we learned from Algebra 1. That's it, just a super, super quick review. And let's go through it last time, just real quickly here. So we have the constant function. It's a straight line, horizontal line, if you like it here. Identity function is the next one. As soon as it pops up, there it is. And we're going to be introduced to some weird ones here in just a bit here. I put in a linear function because linear functions are important. We use them quite a bit. There's a linear function, y equals mx plus b, even though it's not technically called a parent function or in our library, but just used so often here. Okay, next one, quadratic function. And we learned all these little things about it here. The cubic function. The square root function. This one's kind of funny because it starts in a certain time and then just extends, right? It starts at 0, 0, and then just extends. So there's a time where it was not, which is all the negatives. All right, reciprocal function. There's that one. And the absolute value function. Okay, that pretty much covers it for as far as very, very basic functions here that we do. And then we have this extra one here. So now let's get to our notes here. This extra. What's the extra? It is called the greatest integer function. Oh, I don't like that pin. Let me get to another pin I like. Boom, that's better. Whoa, whoa. There it is, greatest integer function. Da, 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 da. Okay, and the formula for it. I got to give you the formula. It looks kind of weird at first here. It's y is equal to, and you got these little brackets that come down, and you have an extra little piece that comes down. So x like this. It's a bracket with an extra piece at the end. So that's the graph version. The function version, which we were interested in, it's like this. F of x is equal to, and again, same exact symbol. It's the brackets with an extra piece at the end. Okay, let's do the graph first, because then it's going to look kind of fun at first here. Here's the graph. And in fact, let me actually zoom in on the graph so you guys can see it. There it is. And let's see, should I go a little bit further? Just a little further down real quick here. Okay, here's my graph. Here's what it looks like. It's a closed dot at 0, 0. And we stretch this out along the 0 up to 1. And right at 1, we're going to put an open dot. So it goes like this. And then what happens? It jumps. It jumps to the next one here. So it's a closed dot at 1, 1. It starts going off to the horizontally to the right. And right at 2, you're going to put another open dot. Somebody slammed the door. Is that what happened? Or did Abe fall off his chair? What happened there? Okay. Okay. We go with a closed dot, horizontal, open dot. Boom. Closed dot, horizontal line, open dot. Closed dot, horizontal line, open dot. And then almost at the end. We're just almost there, almost there. Let's go to the end here. Closed dot, horizontal line, open dot. Closed dot, horizontal line, open dot. Okay, we've graphed it to the right. This is a funny graph. It's called a step function as well. Notice it's kind of like stairs, right? You just go on to the next one, next one, next one. Where is this stuff used? Post office uses it quite a bit. It's any time a function where it's the same price for something and then the price jumps for something else. So with letters or packages, so for the first, it's not really at 0, 0, but it uses the same concept. So for the first, I think it's 8 ounces of your package, or the first pound. Let's go in pounds because it's easier. You have one price. So you have one price here. And then if it reaches above a pound, then you're paying a second price because now it's worth 2 stamps, right? And then it's worth 3 stamps and 4 stamps, depending on how thick the letter is. So that's the same exact concept here. All right, so the only thing that we got to do is we have to still go backwards because, yes, it goes into the negatives as well. And so if you're going back through the negatives, we had -1, -1. It's a closed dot, horizontal line, open dot right here. So closed dot, horizontal line, open dot. Okay, and I'm going to keep on going. Once we're done with the graph, then at least we can start computing this stuff here. So open dot. Close dot, open dot, close dot at the end, open dot, and we are good. There it is. There's the left side of it. All right, sometimes called the step function. Okay, so then let's go to back to this, back to the full graphs here. So we need to figure out all these little things right here. So domain range, is it an even function, odd function? Where are the x-intercepts? Where are the y-intercepts? Is it increasing, decreasing? Is it constant? And this one's a funny one here. Okay, and once we're past this, we'll get going with other things here. So domain, what is the domain? Domain is a set of all real numbers. So from -infinity to +infinity. Notice that if I were to give you an x, you guys can give me a y value. In fact, let's try a little bit of this. Let me jump back to the graph real quick here. We'll kind of jump. If I were to say, what's the greatest integer of point? Yeah, the greatest integer of 0.5. So notice 0.5 would be about right there, right? So we're thinking about what's the greatest integer that's sitting inside 0.5? And we say the biggest integer is 0. The biggest integer that's sitting within 0.9, you know, let's do that. Let's do this. I'm going to jump to a blank slide here because I think it'll be much helpful here for this. So let's do this greatest integer function. If you want to write this down on the side of your sheet of paper, that's fine. If you just want to do it together, well, let's just do it together here as well. So here it is. My function is going to be the greatest integer function. We'll get a little bit more complicated in just a second here. So this, what it's saying is the biggest integer that comes up to this number or lower than this number. And so let me just kind of put a few in here. 1.5, 1.9, 1.999 to 2.1. That would be good for starters here. All right, and off to the side, the way we think about it as we compute this here, we have this little, almost like a ladder going down here. So let's say this is -2, -1, 0, 1, 2, and let's go up to 3. 3. So the greatest integer just means what's the biggest integer that's up to this value or sitting inside this value, or less than or equal to this value. So if you look at 1.5, 1.5 is about right here. Right? What's the biggest integer up to 1.5 without going over 1.5? It's 1. Yeah, because it in a sense it droops, it falls back down to that little guy right there. So if you said 1.9, still 1. Absolutely. 1.999, still 1. Okay. Yep. Absolutely. You guys get it here. Boom. It still drops down to 1. F of 2. Yeah. Now it's sitting right. It's sitting right on the 2 value. It's sitting right on the integer of 2. So in this case, it's just going to be 2. 2.1. Still 2. Okay. Now let's get a little bit more creative here. Oh, PowerPoint is almost not handling this. 2.9. Let's do one more here. Boom. 2. Landon says 2. I agree here. So now let's go this way. Let's go 0.1. Ooh, the fun part here. -0.2. -0.99. -1.01. And -1.35. There it is. There's the ones we're going to try it to do. And I think this little ladder concept is so easy because you can kind of really see what's happening here. All right, give you guys a second here to write those down if you're writing it down. And let's go for it here. So you still have to tell me here. So f of 0.1. And you could show symbols with your hands like Landon if you like. Yep, it's right here, right? 0.1 is right there, just a hair above 0. So that means 0 is inside it. How about a -0.2? Ooh, how fun is that? So on your little ladder that we just made, can you put a little dot at a -0.2? It's going to be like right there, isn't it? It's going to be right there. There's your -0.2. Okay, so question is, what's the biggest integer up to that value but not going over? And just a little bit louder, Isabel, what did you say? -1, absolutely. So notice the ladder that we made. This is -1. Are we good there? Okay. So how about, remember, because negative numbers, they work backwards, right? So how about this? If you go back over here, a -0.99, a negative, it's going to be like right there, isn't it? Right there. There's your -0.99. So what's the biggest integer up to but not going over -0.99? -1. Okay. Biggest integer without going over at -1.01, which is on this other side of this guy. Answer? -2. Uh-huh. All right. And then a -1.35. Yeah, it's about right here. It's about less than even halfway up to -2. So -2. Are we good there, guys? This is the greatest integer function that we have that's the way it works. Let's see, what's some other stuff? When you guys get to do taxes, there's also step functions for taxes. In fact, it's a whole big table that shows, okay, if you make this much money, you're in this category. If you make this much money, you're in this one. So again, it's a step function exactly the same way. Okay, there it is. We introduced these functions here. They're all of them. There's your library of functions or the parent functions. So let's do this here. Let's go back to I got 3 examples for you. We're going to do some fun stuff here. We're going to, we learned these functions, right? But we're going to actually create something called a piecewise function. Sometimes what we do is we mesh these functions together when we want them to be meshed together. So let's go with it here. 3 exercises. Number 1, since we know linear functions very well, we're going to write a linear function for this right here. So it should be a line that we're going to graph. And we're going to use the same exact stuff we used in 1.5. It's just a little different notation here. And so as you graph this stuff, we have to sort of think about this right here. And if you want to write this down, just put y is equal to f of x. If things are functions, I can symbolize something with a y or f of x. All right, do you guys remember this from 1.5? In order to get me a graph, or actually give me an equation, right? Because we're going to write a linear function. I need this little formula right here. Do you guys remember this formula from a little while ago called before the test? In fact, since I'm going to be working on the left side of the graph here, let me or left side of the slide, and then we'll start graphing just to make it bigger for you guys. Okay, question is, do I have my slope? That's always a question. Do I have my slope here? It never says the slope is this, right? So do you guys remember, anybody remember the formula for slope? Awesome. Thank you so much. Perfect. Okay. So if I'm going to do this, if I'm going to write this in terms of function notation, here's your next little slide. You guys ready? Or next little formula. It's still going to be x2 minus x1 on the bottom. On the top, instead of writing the y values, it's going to be f of x2 minus f of x1. So there's your function notation. So notice my y's changed into f of x's. So now let's kind of do this little piece right here. So if that right here, there's my x sub 1, right? I'm plugging into my little f function right here. So plugging in a 1 into the f function gets me f of x sub 1. Are we good there? That's what it's. And then we got the same thing here. Plugging in a 4, when we plug in a 4 called x sub 2, we get out f of x sub 2. So again, it's just kind of just learning the notation of functions here. Ready? So let's go with it here. So f, or our slope is, and I like to write the x values first because it totally makes sense to me this way here. So it's going to be 4 minus 1, because those are the x values. Those are the stuff I'm plugging in. My plug-in values is 4 and 1. My output values are 0 minus 3. Okay, and you guys talk to me. Just see if this makes sense to you guys, because I don't want to confuse you. Just notice where all the numbers are coming from. Okay, with that said, let's go with it here. So our slope is 0 minus 3 is negative 3. 4 minus 1, oh, that's cool. That just becomes a negative 1 for my slope value. If you did want to convert these into x and y coordinates, they kind of go like this. If you did want to convert it, this is 1, 3. That's what this converts into. This one's going to be 4, 0. That's what this converts into as well. So the input, notice the input is the x, and whatever the output is, it's the number what f of x is equal to. Okay, so we got that. Boom. And now we got to pick which point we want to use. I'm going to use 1, 3 for my point here. So let's go with it. Y minus 3 is equal to my slope value, negative 1, and it's x minus 1. And we know how to do this already. Can you solve for y? Let's see, we distribute the negative 1. So negative x plus 1, there it is. And then we're going to add 3 to both sides. Negative x looks like plus 4. There it is. Okay, so before we learned about functions here, that's what was our linear line. So now that we learned about functions and we're so sophisticated, here's what we're going to do. We're going to write this instead of graph notation, which is what it's listed as, or it's sometimes called two variables. We're going to write this in terms of function notation. You guys ready? 5, 4, 3, 2, 1. We're going to change the y into f of x. There it is. There's our answer in function notation. Then that's the only thing that changes right there is f of x. All right, now all yours. Can you guys graph this? Can you guys graph negative x plus 4? All right, it's the same thing as, remember the graphing of this is going to be the same as mx plus b, right? As long as we know that one right there. All right, and where do we begin? Where do we start? At 4 along the y-axis, right? So right over here, right at 4, we should put a little dot right there. And then our slope value, right? The way we move is a negative. Technically, it's a negative 1 over 1. So we're going to move down 1, and then we're going to move 1 over to the right each time. So from the 4, we'll go down 1, 1 to the right. And as soon as you do 2 dots, you're done because you can get a straight edge and connect the dots and you're good to go. You can keep on going though. Just gives you a little bit more accuracy on the graph if you just kept on going down 1 over 1. We could also go up 1 and 1 to the left. Okay, and I'm going to move my computer here just so I can get a nice straight line. All right, and arrows at the end because this guy is going to keep on going. Arrows on that end, arrows on that end. Boom, we're good. There it is. So the graphing is the same. We just introduced this extra new notation right here. So for functions, if things are functions, we can write it as f of x. That's kind of what we did. Graphing for linear functions, exactly the same. Getting the equation for it, exactly the same. There's no new thing, just except for that f of x. Okay, so I think we're ready. We're ready for this little greatest integer function just to practice with it here. So everybody okay with 1? Just want to make sure. Example 1, good. Anybody need more time with 1? Going once, going twice. No, okay, so jam. Example 2. So notice this is the greatest integer function, but then you can add stuff to it as well. You can add 1 to it. You can actually have a multiplier in front as well to it. You can do a whole bunch of stuff. The Postal Service, since stamps are what? I think they're 41 cents now. You guys talk to me. Are they 41 cents? Anybody know? I don't know. Okay. If I was to do a step function for the Postal Service, my step function would be looking like this here. So it's 4.1 as a multiplier to the greatest integer plus 1. That's the way I would. So you add 1 to it, and then it's 41 cents, and then you go from there. I think so. Okay, this one has a greatest integer function, and then you're going to add 1 to it. That's what this guy's going to do. I think that's true for the Postal Service. It's a multiplier, but you got to get to 1 though first. Oh, you know what? Hold on. There it is. For the Postal Service, it's actually like this. It's 0.41, and it's the greatest integer of x plus 1 inside the greatest integer. There it is. There's your formula for the post office right there. Okay, the formula we're dealing with, much simpler. It's going to be the greatest integer, and then you add 1 to it. So ABC, plug in x is equal to -1, x is equal to 2, and x is equal to root, actually 3 over 2. And then we'll do a quick graph of it. Okay, give you guys 30 seconds here. Try it yourself as you're thinking about it. And give you 30 seconds to try it. Okay, my mic was not working. Okay, let's try this. Let's see if this makes sense here. Plugging in a -1 into here. And the greatest integer inside -1 is -1. Add 1 to it, should be a 0. Are we good? Plug it in. I should actually write it in as -1 here. So as 2, greatest integer within 2 is 2, and 2 plus 1 should be a 3. Okay, and this one, much easier to write it as 1.5, right? 3 halves the same thing as 1.5. And the biggest integer within 1.5 is just 1, and 1 plus 1 is 2. So you should get an answer of 0, 3, and 2. If you do that, you did great. If I were to graph this function, now you guys don't have to, because the homework says you don't have to. Actually, you do have to sketch this function. So yeah, this would be a good one. There you have one homework assignment of actually graphing this function. Notice this little extra little +1 right here. So if we were to go back to our step function right over here, and let me zoom in on it. All we're going to do, if we're adding 1 to something, all these little pieces are going to go up by 1. So it's a step function. Add 1 to it. So you just lift each one of these small little linear lines, and you lift it up by 1. Even the negatives as well. You lift up the negatives by 1. And so if I were to graph this, I would take this function. So we start off at 0, 0. Notice that we went up to 1 and we did an open dot over here. So if I were to graph this function, oh, let me go. Sorry, let PowerPoint catch up over here. There it is. Now let's do our graph here. So greatest integer +1. So instead of starting at 0, 0, it actually starts off at 0, 1. Goes horizontally across. Jumps to 2 horizontally across, jumps to 3 horizontally across. So notice that each of these ones from the original graph, I just picked up by 1. So instead of it being at -1, -1, it's at -1, 0. And the question comes up usually from students is, Mr. Rajiv, how many of these do we usually draw? Do we have to fulfill the whole entire line? No. And customarily, we draw about 6 of them. If you got about 6 of them or 7 of them in there, that's fine. You don't need to complete the whole entire graph each and every single time. Okay, so there it is. There's our step function called the greatest integer function. Okay, you move on here. So now that piece is done. Next one. So notice we have these library of functions right over here, right? And you guys talk to me here. Are we all good there? I have my volume up. We're going to put them together now. So here's the way we put them together. Easy one to put together. And this is called piecewise functions. We're going to take the functions that we know. We're going to cut them off to be one function at a certain time and a different function at a different time. So it's kind of like 2 functions being put together. Let's do an easy one first. These are 2 linear functions, since we know how to do linear functions already. And let's jam. So 2x plus 3, as long as, so we're going to use this function as long as we are at x is less than or equal to 1. So this little 1, right, this is our kind of like the x value that changes the function. Anything above 1, we're going to use the bottom function. So 2 functions we're using, they're both linear, but let's go with it. The only thing we've got to be careful for is which one has the less than or equal to symbol. Now, the equal to is important here. The top one has it, so this one's going to be our closed dot. This one's going to be our open dot because we're not going to include the 1 for that function on the bottom. We are going to include the value at 1 for the top function only. All right, so see if you guys can stay ahead of me here. So let's graph 2x plus 1. It's the same thing as graphing mx plus b. But we're only going to graph it up to a positive 1. So let's see how this starts. So we start off at 3. Everybody agreed there? We're going to go up how much? 2. Yes, Landon, it says 2. I agree. We're going to go up 2 and 1 to the right. So we're going to have this little guy right here. Boom. But notice that's our cutoff, right? We don't use this function past 1. So here's what the graph looks like. It's only on the left side. Goes like this here, only on the left side. Okay, now we're going to use, are we good with the first graph? Are we good with the first graph? Let's do the second graph now. It's going to be the negative x plus 4. So the way we still graph it is mx plus b, but we have to be a little bit mindful of this graph is only going to start with anything after 1. So we're still going to find 4 like we normally do, but we're going to start erasing. So careful. If you guys have pens with you, don't use a pen, use a pencil. So here's what we got. I got graph at 4, and we're going to do what with it? I think we're going down 1 over 1. Is that right? But right at 1, open dot or closed dot, we're going to use a open dot because we are not using the 1 as our value input. So let's go down again here. So let's go down 1 over 1, down 1 over 1. We can probably stop there. So the graph goes like this. Open dot at 1, 3, and the graph goes down this way. Arrows here. And let's erase this little 4 one that we did over here at 0, 4. Okay, these are a little bit tough to get used to, but once you do a few of them, you're like, oh, totally get this now. And then you go from there. So I want you guys to notice here. So notice at 1, x equals 1. On the left side of this, we use one graph. And on the right side, we use another graph because our divide line is 1. Okay, does that make sense? Is that cool? Okay, let's do one more like it. And let's see if this is going to be easier to sort of see it here. Let's see, we got what, 10 minutes left? Yeah, I think let's try one more. Whoop, not that one. Example 4. And this would be a little bit easier. Just want you guys to sort of see the function here. So I have myself a function that says this. So I think you should be able to see it from the parent functions here. So let's see, 4. Now I'll let you guys write it down first. So let's see, if anything, if we're using negative x's, notice it's x is less than or equal to 0. For any negative x's, the function that I'm going to draw is x squared. And then for anything that's higher than 0, I'm going to use the absolute value graph. So my divide now, my graph divides right at 0, where x equals 0 along the y-axis. So can you guys remember, or back to x squared? What does x squared look like? How is it drawn on the negative side of the graph? And if you need to refer back to your graph, you can do that. You can go over here. You say, oh yeah, that's right. Look at this. Anything on the left side of this graph. So anything right here It's this side right here. It's the left side. Can we graph that on the left side? So in this case, it's going to be, I guess we should start off with 0, 0, right? Because we can use 0. This one says we have a closed dot at 0, 0. And we're going to go to the left because we're using the negative. So -1, +1, -2. If you square it, becomes a 4. -3 is all the way up at 9. So that's all the way up here. So I'm going to just graph it like this. Make a better parabola here. Coming down, and it goes like this. Okay. And you guys talk to me. Are we? Okay. Does that look like a x squared on the left side? Cool. On the right side, we're going to use the absolute value of x. Now, it's a V-shaped graph, right? But we don't want to look at the left side of the V-shape. We just want to look at the right side of the V-shape. And so back to our absolute value. It's going to be this one, but we don't need the left side. We're just going to use this right side right here. It's this side right here. So dun, 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 dun. Let's go here. Perfecto. And it's going to go like this. It's going to go from, oh, you know what? Look at this. Notice that these guys connect each other. Notice this one is supposed to be an open dot at 0, 0, but x squared was the closed dot at 0, 0. So if open dot is actually sitting on top of a closed dot, it just becomes a closed dot. We're good? Because it's covered by at least one graph. So the next one would be 1, 1, 2, 2, 3, 3. And notice we can now graph this guy this way. So left side of 0 is an x squared. The right side of 0 is a linear function graph. Okay, are we good? Does that make sense, guys? Right there. So notice that there's no open dots here. The only time you have an open dot if the graphs don't connect to each other, like this one that we did for example 3. You have no connection, you got to make sure, you got to figure out where the open dot and the closed dot is. Which graph has the closed dot? Okay, boom, and let's go backwards. Let's go backwards here. So now I'm going to take you on this little journey. Can you write for me the piecewise function here? Oh, taking it a little different on you guys. So let me zoom in. So let me zoom in on this little piece here. Boom. Okay. So let you guys think about it. Start writing off to the side. We can at least start off like this. F of x is equal to, looks like there's just two graphs here, right? So we're going to make a little braces to fit inside two equations. And this is cool stuff, cool part over here. So going backwards. Okay, so you guys talk to me here. Where's the break occurring? Where's the break? Yeah, at 1. You could tell it's occurring right at 1 because it's like right there. Boom, there's your little divide piece. And then the question is, which function? Is it the first function or the second function that gets to hold the 1 as the closed dot? Let's see real quick. We're just trying to get the closed dot and open dot here. So I'm thinking like this. Anything that's x, oh, is it 2? Sorry, Isabel, you are totally correct. It's 2, because that should be a 2 there. The 1, 1 is right over here. Thank you. So x is less than or equal to 2 is going to be one graph. And then it's going to be x greater than 2 is going to be the other graph. Are we good? So our divide line is at 2. Thank you for catching that. That would not be good if you guys go on vacation trying to ponder, why did he put a 1 there? Why did he put a 1? Okay, boom, there's that. Now the question is, you guys talk to me here. What does the first graph look like? It looks like x squared. You guys agreed? Doesn't that look like an x squared? That first function coming in from the left? It has -1, -1. Oh, sorry, -1, 1, 0, 0. It has a 1, 1, and a 2, 4. Perfect. So this side is an x squared. Next function is a linear function, huh? It's going to go down. Okay, so two ways to do this. I wish it would have hit the x-axis because then we know exactly where it hit. But the problem is it doesn't. Now we got to figure out the equation. Do you guys remember trying to get equations of linear functions? I think we do this little guy. And before we do that little guy, since we don't know what our slope is, we got to figure out the slope. Ah, man, back to example 1 now. So back to slope here, and we're almost done. So I'm going to label this guy as our x1, y1, x2, y2, and can you guys quickly find for me the slope of the line? So a little bit of work on this one. The x squared was pretty easy to see because that was one of the parent functions. Like, oh, that's easy. That's just x squared. Difficulty was in trying to get these linear functions. Okay, anybody got the slope yet? So y2 minus, oh, happy face here, minus y1, x2 minus x1 pops in as, let's see, y2 is a 0, minus 4 on top, 7 minus 0 on the bottom. Oh, so 7 minus 3, sorry, 7 minus 3. Negative 4 over 4, and I got myself -1. Did you guys get -1? Oh, now you guys tell me you get -1, but no one offered the answer before. Oh, Isabel did? Okay, thank you, Isabel. Okay, and I'm going to use 3, 4 as my point. So how about this? Y minus 4 equal to -1, x minus 3. And let's solve for y. So -x plus 3 looks like. Add 4, add 4. And we're almost out of time here. So we get ourselves y is equal to -x plus 4. Now, we don't need the y in it because remember, you're using f of x. So we just need this little piece right here. And -x plus 7. Thank you. I think I just need to go on vacation at this point. Okay, let's go with -x plus 7. There it is. Boom. Okay, guys. One more thing I got to mention to you guys is I am going to do grades during break, and I noticed that a couple of people have been emailing me in regards to they don't see something in Google Classroom. So please do, if you need to email me, if you're turning in work, don't see something, I'll respond to those probably tomorrow or Wednesday. I'm going to try to get all the grading done by Thursday. And then if you're missing any assignments in Google Classroom, please look at Google Classroom. I know I emailed a few of you guys that I saw were missing work. Please do so because I'm going to try to catch up with all the grading, and then I'm going to have to put in zeros if I don't see work from you guys from there. Anyways, besides that, enjoy your vacation. See you guys next year, and at least to take some time to relax. Thank you guys. Thank you so much. And Isabel or somebody or Nat, if someone can spray down the chairs, please. Isabel, thank you so much. Yep, and just kind of see, think about where students were sitting. Yep. Very true. I will start that as soon as I'm physically back there again. Thank you so much. Thank you, Net, for wiping. All right, you guys. Bye-bye. See you next year.